Hi there, welcome to my channel mathssl. I'm speaking Thaqib Latif. This is the question number 9, the 9.1. Complete the following statement so that it is true. The exterior angle of a cyclic quadrilateral is equal to. First question, I need to complete the statement. The exterior angle of a cyclic quadrilateral is equal to interior opposite angle. So interior opposite angle. 9.2. In the diagram below, O is the center of the circle, AC is a tangent to the circle at B. D and E are points on the circumference of the circle. DE, DB and BE are joint. Prove the theorem that states E angle BC is equal to angle D. So this is a tan chord theorem. So we need to prove the tan chord theorem here. So must remember, we need to prove E angle BC, which means angle B1, is equal to angle D, tan chord theorem. Now the second question, I need to prove the tan chord theorem. I'll show you how. So I need to do some construction here. There's many ways to prove this one. I choose this way. This is the easiest way. We need to draw a diameter, BOF. So draw diameter BOF. And after that, join FE. We need to join FE. So first of all, I draw diameter BOF, then I join FE. So I need to write in words, construction, draw diameter BOF and join FE. Now let E angle B C must be equal to X. So EBC, this angle is equal to X. So we let EBC, this angle B1 is equal to X. Now angle E1 and plus E2. So this is my E1, this is my E2. E1 plus E2 is going to be 90 degree angle in the semicircle, because this is a diameter and this become 90 degree angle in the semicircle. This one 90 degree angle in the semicircle. So angle E1 plus angle E2 is going to be equal to 90 degree, or you can say FEB is equal to 90 degree, because angle in the semicircle. This is diameter, this is 90 degree angle in the semicircle. So I must give the reason. Angle in semicircle. Angle in semicircle. So this is my reason. Now B2, angle B2, which is going to be this one. I say this is my B2. If this is B1, this is B2. This is going to be a 90 minus X, tan perpendicular to radius. But remember, AC is a tangent. So this whole angle from here till there is a tan perpendicular to radius is going to be 90 minus X, because X is already here. So it's 90 minus X. So the angle B2 is going to be equal to 90 degree minus X. The reason is tan perpendicular to radius. Now angle F. So this is your angle F now. Let's remember E1 and E2, or you can say FEB 90 degree, because BOF, this is diameter, this is angle in semicircle. Now this is 90 degree. Now this whole angle from here till there, tan perpendicular to radius 90 minus x. Now we're using this triangle now, FEB. In this triangle we got this is 90 degree, this is 90 minus x, because angle B2 is 90 minus x. So angle F gonna be a x, sum of angles in triangle. Have a look. So angle F is gonna be equal to x. Why? Sum of angles in triangle. Sum of angles of triangle. Sum of angles of triangle. This is my reason. Why I say angle F is equal to x? Because angle F, have a look here, angle F plus this angle E plus this angle B2, we're using triangle FEB, must be equal to 180 degree. So the angle F we don't know, and angle E we know 90 degree, and angle B2 we know 90 degree, 90 degree minus x, and is equal to 180 degree. Now here this become 90 plus 90 gonna be a 180. So the angle F plus 90 plus 90 180 degree, and positive and negative is only x, negative x is equal to 180 degree. Now from here angle F we need to find out. So the 180 degree, this positive become a negative 180 degree, this negative become positive x, this is cancel, so we only left angle F is, so the angle F is going to be equal to x. That's how we get the angle F is equal to x. So now angle F is equal to x, so must remember now this angle is x. Now I can use angle in the same segment. Have a look here. So the angle F, go back using the chord E and B, this chord, and this chord as well, forming an angle here, angle D. So this is going to be angle D, it's going to be also equal to x, angle angle in the same segment. So they will prove now. So I'm going to say angle D is equal to x. Why? Angle in the same segment. Now therefore we prove, therefore E angle BC is equal to angle D. They will prove. So have a look here. So this is tan chord theorem. Angle between tan and chord. This is a chord. So they forming an angle here. Have a look. Is equal to x. So we prove. So this also x, B1 and D is also x. Angle F is equal to x, and you can see go back to the chord EB. So the chord EB forming an angle F, and as well you can see forming an angle D, angle in the same segment. So they we proved tan chord theorem. Question 9.3. In the diagram below, FGH is a tangent to the circle with center O. BOG is a diameter, so the BOG is a diameter. This is a BOG is a diameter. AB parallel to EG, and G angle G1 is equal to 59 degree. CD is equal to DE. So this is the information of the sketch. So the first question, he said determine with reason the size of C angle DO. So the first question, C angle DO. C angle CDO is going to be equal to 90-degree line from center to midpoint of chord. So this is going to be 90-degree. Line from center to midpoint of chord. CDO is going to be 90-degree line from center to midpoint of chord. So I'm going to say, so C angle DO is equal to 90-degree line from center to midpoint of chord. 9.3.2 angle B1. So we need to find the angle B1. That's going to be tan chord theorem. Between tan and chord. So this is the chord and this is the tan. Angle between tan and chord, and this is a 59-degree. Now this chord forming an angle, the angle B1. So the angle B1 is going to be equal to 59-degree. So tan chord theorem. So angle B1 is going to be equal to 59-degree tan chord theorem. 9.3.3 angle G2. Now I need to find the angle G2, this one. Angle G2. So must remember, BAG is going to be equal to 90-degree. Angle A is going to be equal to 90-degree angle in the semicircle. And then I'm going to use the sum of angles in triangle to find the angle G2. Because B1 is 59-degree, angle A is 90-degree, and the G2 I'm going to find through sum of angles in triangle. So B angle AG is equal to 90-degree angle in the semicircle. Angle G2 is going to be 180-degree minus 90-degree minus 59-degree is equal to 31-degree angle sum in triangle. 9.3.4 angle G3. Now we need to find the angle G3. This angle G3. AB parallel to EG. This is a transversal line. So angle G3 is going to be equal to B1, alternative angle. So angle G3 is equal to 59-degree alternative angle AB parallel to EG. 9.3.5 angle C1. Now we need to find the angle C1, this angle C1. This is easy and quite interesting question. So the C1, have a look here. So the C1. So it go back to the join the point B and then as well point A. So this is a chord. AB is the chord. And now AB forming another angle, they G2. So angle in the same segment. So angle C1 is going to be equal to 31-degree angle in the same segment. 9.4. Prove that AC parallel to OD. Last question, we need to prove AC parallel to OD. This AC parallel to OD. We need to prove this one. So 1, 2, 3, 4. 4 points on the circumference. So this is going to be a cyclic quadrilateral. So angle D, so we earlier proved CDO. So this angle is 90-degree. So if I can prove that angle C2 also 90-degree, so then I can say this AC parallel to OD, I can use co-anterior angle. But remember, to prove lines are parallel, so you need to prove one of the three angles, corresponding angle or alternative angle or co-anterior angle. So I can prove here co-anterior angle, then I can say AC parallel to OD. How we gonna prove angle C2 is equal to 90-degree? So I'm gonna use opposite angle of cyclic quad. But remember, opposite angle of cyclic quad here. So we have the G2, we have the G3. So the G2 we have 31-degree and G3 we got 59-degree. So 180-degree minus these two angles, and then we'll find that the angle is going to be 90 degree, and then there we can prove this both is 90 plus 90 180 degree, a co-ordinate angle, and therefore we can say AC parallel to OD. So angle C2 gonna be 180 degree minus 31 degree minus 59 degree 90 degree, opposite angle of cyclic chord, and the angle C angle DO plus angle C2 is going to be 180 degree, so which means 90 plus 90 180 degree, so therefore AC parallel to OD coordinate angles. Please like and subscribe my channel. If you have any question, comment below. I will assist you. Have a nice day.